All right, friends, here we are. This is the last page, thank goodness. This has been long. Sorry I'm boring, but I don't know how to make this super exciting, I'm not gonna lie. I can show you pictures of my cute dog. You wanna see a picture of my cute dog? Okay, hold on. Let's see. Like this. Here, that's Fitz. Is he upside down to you? He's upside down to me too right now. Hi, little Fitzy. Can you say hi, Fitz? Oh, there he is. Hi, Fitzy. Okay, sorry. Now I just woke him up. Who knows what that's gonna do? All right, I was trying to make it more exciting for you by showing you my dog. I don't know if it worked or not. You should see this contraption I've got going on to be able to record this. Okay, here we go. Last page. We got this. Wake up. Oh, the fun part, the graphing. Here we go. So graph the polynomial using all the techniques that we have learned. We're going to start with the degree of the polynomial, use that our end behavior, and then do some x and y intercepts. We're going to do some factoring. It even tells us to factor right there. So end behavior for x cubed, that means that as x approaches negative infinity, f of x is going to approach negative infinity. And as x approaches positive infinity, f of x is going to approach positive infinity. That means that over here on my graph, it's going to be going down here, and it's going to be going up here for the end behavior. Okay, so that's one of the things I needed to pay attention to. Now I'm going to take a look at this and factor just like we did on the last page on problem number 10. So let me see if I can turn that. So it's okay. So I am going to try to do a factor by grouping here. If I look at those two terms, they both have an x squared in common, so I'm going to factor it out and write it as a product with what's left over. Now I'm going to look right here, and I see a -1 that can come out, and I'm going to write it as a product with what's left over. Now if I look at this big binomial, I see that both terms have an x plus 2 that can be factored out and written as a product with what's left over. Wow, that looks a lot like what we just did. That's not by accident, friends. So this gives me x plus 2 equals 0. So x equals -2 is one of my x-intercepts. And then this one is x squared minus 1 equals 0, which is x squared equals 1. Take the square root of both sides. X equals plus or minus. The square root of 1 is 1. So this is 2 more roots right here. So I've now got 1, 2, 3 answers. I expected 3. These are my x-intercepts. I also need to find, these are my x-intercepts. I also need to find my y-intercept. And to find my y-intercept, that basically means I want my x value to be 0. So I like to go back up to my original and basically do f of 0. That's going to give me my y-intercept. So 0 cubed plus 2 times 0 squared minus 0 minus 2. That's a 0, that's a 0, that's a 0, and so it's equal to -2. So what I just figured out is my y-intercept is 0, -2. X is 0, y is -2. Hopefully that works. Okay, so now I'm going to come over here, and it's going to be graphing madness. So take a minute and set up. We're going to do a sketch of the graph. It's not going to be perfect by any stretch. I want to do my spacing as well as I can here. It doesn't have to be measured perfectly, but it should be pretty decent. Okay, and now I'm going to go back over here, and I'm going to grab my x-intercepts, my 3, and I'm going to go put them on. So I should have one at -2, -1, and 1. I also know that my y-intercept is 0, -2, so it should look like that. Okay, so basically what's happening here, you see how my end behavior tells me that I'm starting down here. I'm going to go up and through that one, and I'm going to turn and come back down and go right through here and then back up and end in an upward position like that one. Okay. I don't know exactly how high up to go. It could be tall and skinny or not. I'd have to do a little bit more investigating to figure that out. But this is a good idea right here of what the graph looks like. I use my end behavior to know which way my arrows were going to be going. And then I use my x-intercepts and my y-intercept to give me some good info there. All right. Oh my gosh, if you missed it, you get to hear it all again on our next problem. I'll go through that logic again. Okay. So this one, if I tried to factor it by grouping, it would not work because it doesn't work. Factoring by grouping doesn't work on all of them. So we actually had to give you one of the zeros to be able to do this. So I am going to use synthetic division. Up here I factored and I didn't need synthetic division. Down here, they're giving you a factor or we're giving you a zero, and so you do need to use it. And this right here is what I am going to put in the box. Okay, and now I'm going to go 1. So you have to be a wily cat on these problems. You don't know. You have to use lots of different tools to solve these. Check, make sure you got everything. Cube, squared first. Okay. Now I better get a 0 when I do this. If I'm doing it correct, I should. I did. Perfect. Okay, so that took it from x cubed. This is now x squared. As soon as I get down to a quadratic, I'm pretty darn good with quadratics and I know how to use them. X squared plus 3x minus 4. Okay. So this is x equals 1. That's not shocking. I already knew that one. This one right here is going to be hopefully factorable. It looks like it is, but let me double check. If I put a 4 and a 1, that gives me 4x, that gives me an x. If I make this positive and that negative, that'll work. Yay. So x is going to equal 1 and x is going to equal negative 4 here. So now I just got 3 x-intercepts, which is what I expected because it's cubic. Those are x. Now to find my y-intercept, let me label this x-intercept. Okay, to find my y-intercept, I'm going to find f of 0. So I'm going to go back up to my original, and I'm going to put zeros in. All of that just went to 0 plus 4. Double check. Okay, so I just figured out 0, 4 as my intercept. Okay, so now I'm going to take that intercept and these 3, and I'm going to go put them over on my pretty graph. Oh, I forgot to do end behavior. I will get to that in just a moment. It's going to be the same end behavior as the last one. I hate making these graphs. How about you? I mean, I hate doing the labeling of that. I don't hate actually graphing it. That part's not hard, but setting them up is kind of irritating and tedious. So because I'm looking right here at my leading coefficient test, that's what you call that. I'm looking here because this is cubed. As x approaches negative infinity, f of x is going to approach negative infinity. That's telling me it's going to be going down out here. Then as x approaches infinity, f of x is going to approach positive. Okay, so that's telling me this is going to go up. All right, so I got all of that, by the way, by looking right here. So because that's cubed, I know the arrows are going to go in opposite directions. If it was to the 5th, that would be true. If it was to the 4th, they'd be going in the same direction. Then the second thing I look for besides that is I look out here and I see, is it positive or negative? And because it's positive, I leave it alone. If it was negative, I would flip them. Okay, so what am I doing? Oh, I'm going to put x equals 1. That was one of my intercepts. Oh, did I have a double one? I didn't even pay attention, but I did have a double root at x equals 1. And then negative 4, 1, 2, 3, 4. And then I also need 0, 4, 1, 2, 3, 4. Okay, so, Okay, so a double root is a really cool thing. Hopefully you have heard, I hope this is not the first time you're hearing this, that you've been hearing it all along. When you have a double root, that means that the graph is actually going to turn right there I say it's going to kiss the x-axis and then turn around and go back. So what I'm trying to say is I'm starting down here. I'm going to come up nice and steeply. These are steep. It's probably going to go up above like that. It's going to come back down. It's going to kiss the x-axis at x equals 1 and then turn and go back up. I know that it turns and kisses it right here because anytime there's a double root, it doesn't actually go through. It turns right there. So let's see, can you see all this? I also know that it could be going way up here. I'd have to investigate further to see exactly how far up it goes. We're not asked to do that. We're just asked to give a sketch, so I'm going to do that. It looks something like that. My guess is it goes way, 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 way up to some ginormous number, but I'd have to actually do that to figure it out. And then it would come back down. It would go through that, turn and kiss at 1, and then go back up in the other direction. So when you've got a double root, it turns right there. It does not go through, it turns. And so that's how I end up having 2x intercepts with those that end behavior. Okay. Oh my gosh, could it be true? Are we really at our last problem? Poof. Ooh, this one we're giving you 2 of the 4 factors. So this has 4 solutions, and this is them telling us 2 of them. Okay, so here we go. We're going to do synthetic division twice. Once with -1. Can you see? Yes, you can. 1, -2, -7, 8, and 12. 4, 3, 2, 1, 0. Okay. 1, multiply, I get -1. Add, I get a -3. Multiply, I get +3. Add, I get a -4. Multiply, I get a +4. Add, I get +12. Multiply, I get a -12. And my remainder is 0, which it should be because they're telling me that these work. When they say that I get a 0 right there, that's telling me that -1 should give me a 0 right here. So I just took my x to the 4th. It is now x to the 3rd. I am going to use my other answer, -2, and use these 1, -3, -4, and 12. Okay, bring that down. That gives me a -2. That gives me -5. 10. That gives me, when I add a 6, that gives me a -12 or a 0. This is now cubic. Yay! I want it to be a cubic because once I get down to a cubic, I can factor or use the quadratic formula. All right, so f of x is equal to x plus 1, x plus 2, x squared minus 5x plus 6. Now, where did all that come from? The x plus 1 is coming from this right here. The x plus 2 is coming from here. The x squared minus 5x plus 6 is right there. Okay. Set this equal to 0 and solve like a mad person. We obviously already know the first 2. And now we need to figure out this one. So x equals -1, shocking. X equals -2, shocking. Let's factor. 6 is actually tricky, believe it or not. It could be a 1 and a 6, or it could be a 2 and a 3 to get that -5 right there. So I'm going to go with the 2 and the 3. I'm going to make them both negative. That actually gives me a +6 right there, so that works. My middle terms work out. So x is equal to 2 and x is equal to 3. So now I've got 1, 2, 3, 4 x-intercepts. The y-intercept is going to be f of 0, which if you go all the way back up here to our f of x, I'm going to put in zeros where I see x's. Can you see me? So I'm using that original from the very top. Do I actually care about like 0 squared? No, it's just 0. It's going to be a 0. The only thing I actually care about here is the 12 at the end because each of these terms is going to be a 0. And so I get 0, 12 for my y-intercept. Okay, I'm going to come back up here and I'm going to look at my end behavior. Nope, too high, Stephanie. I'm going to go right here and look at my end behavior. So for in behavior, I am checking out right here the x to the fourth. Because it's to the fourth, that tells me that both of these are going to be up. Okay, so that looks like this. As x approaches negative infinity, f of x will go to positive infinity. As x approaches positive infinity, f of x will also approach positive infinity. Again, that's just telling me up and up. And if you were in my class, you'd see me doing my fingers. I go up and up, or I, do them down if need be. In this case, they're both up. So now I'm going to sit here and, for the last time, do all these little hash marks. 1, 2, 3, 4, 5. 1, 2, 3, 4. This is tedious. That means takes detail, is not fun. Okay, and so now I'm going to go grab all 4 of these x-intercepts and put them on my new graph here. -1 is one of them, -2, 2, and 3. I also know that my x-intercept is at 0, 12. Oh, good Lord. 0, 12 is going to be 1, 2, 3, 4, 5, 6, 7, 12. There, I just made it up. I'm not going to lie. So I'm going to say that's 12 way up there. Okay. So here's what's going to happen. I'm going to be coming from here. It's going to go down, come back through here. It's going to go all the way up there and touch. Okay, here we go. It's going to be nice and steep because these are big numbers. So it's going to be like... You have to make that sound when you do it. Maybe something like that. That's not perfect, but these right here could go way down. I mean, it could come way down here, go up, way up, come way down and way up. But this is good enough for what we're looking at right now. All right, friends, we've just been together for like 2 hours, it feels like. I don't know exactly how long it's been, but it's been a long time. I hope this helped you. Again, if you need me, my name is Miss Hass. I am down in F5. You can come down at lunch on Tuesdays, Wednesdays, or Thursdays, anytime. Okay, take care. Bye.